So we just looked at a few examples where we were solving exponential equations that have common bases, so the same base. But now we're going to focus on solving exponential equations where the bases are different. So notice, for example, here I have base 2 equal to an exponential expression that's in base 3. So the first thing that we're going to do is you can either take the common log, log, or you can take the natural log. So here, because it's not in base e, you can actually take the natural log or the common log of both sides. So remember, this is an equation. So if I take the natural log of the left side here, to keep the equation balanced, whatever you do to one side, you would do the same thing to the other side. So on the left, I've got the natural log of 2 to the x is equal to, on the right, the natural log of 3 to the x plus 1. And then now that I have it written like this, I can use the power rule. So you want to apply that power rule to rewrite each expression. So on the left, the natural log of 2 to the x is the same thing as x times the natural log of 2. And on the right, this is the same thing as x plus 1 times the natural log of 3, okay? So on the right-hand side here, I can uh, multiply the natural log of 3 times x, and then add 1 times the natural log of 3. So I'm just basically distributing the natural log of 3 to each term inside parentheses there. And on the right-hand side, I'll go ahead and bring down x times the natural log of 2. So here I see that I have terms that have x in it. So what I can do is try to combine those terms. So I can subtract x times the natural log of 3 on both sides to bring all my x terms to the left side of my equation. So when I do that, on the left, I've got x times the natural log of 2 minus x times the natural log of 3, and on the right-hand side, we've got the natural log of 3. So here, hopefully you can see that I can factor out, so I can factor out this x, and that leaves me with the natural log of 2 minus the natural log of 3. And then on the right-hand side here, I still have the natural log of 3. So what I can do now on the left-hand side is I can use, so right here, I can use the quotient rule. So let me kind of move to the right here. I kind of ran out of space there. So I can rewrite this using the quotient rule. The natural log of 2 minus the natural log of 3 is the same thing as the natural log of 2 over 3. And then on the right-hand side here, I still have the natural log of 3. So then my last step here, hopefully you can see, is I would just divide both sides by the natural log of 2/3, because that cancels out on the left. And then whatever you do to one side of the equation, you got to make sure you do the same thing to the other side. So final answer, x is equal to the natural log of 3 divided by the natural log of 2/3. I'm sorry, the JU logo is in the way there. But that is how we would solve this problem algebraically. So you can actually leave your answer like that. I'll write it to the left here. X is equal to the natural log of 3 divided by the natural log of 2/3. And so this is your exact solution, but you can actually type this into your calculator and get an approximation. So I'll show you that in the next slide. So we just solved this equation algebraically, and we came up with a solution that x is equal to the natural log of 3 divided by the natural log of 2/3. And this we said was our exact solution. On the calculator here, you can simply type in using the natural log button. So you would type in the natural log of 3 divided by the natural log of 2/3. So you see I've typed it here in the screenshot. And it tells us that the approximate solution is negative 2.7. We'll round it to 2 decimal places. So that's approximately negative 2.71. What I also have here on the left is a screenshot of these two equations. So the orange equation is the equation 3 to the x plus 1. So that's this guy, 3 to the x plus 1. And the green equation is the equation 2 to the x. So this green curve here is 2 to the x. And we want to know where they equal to each other. And hopefully you can see down here the point of intersection the calculator gives us is at x equals negative 2.71, which is what we got when we put the natural log of 3 divided by the natural log of 2/3 into our calculator.